All right, guys, I think we can kick it off now, and the other people can join in as they connect with us. So, welcome to our first Python Karachi and Elastic meetup for, I think, this year. We tried doing this in um, March, I think, and that was right before the COVID situation happened. So as everyone is doing uh, meetups online, so we thought, might as well do this online as well. So we have three awesome talks for you today. And I'll kick off with an introduction of what is Python Karachi, and then hand over to Junaid to talk a little bit about the Elastic community as well. And then we'll continue on with our talks. So Python Karachi came to being about a year and a half ago, and this was something I started, and me and a bunch of other friends here in Karachi. We thought that the space was missing. There are a lot of people who wanted to learn Python, learn things about Python, but there wasn't a single platform where everyone in this place in Karachi was actually just talking about it. There were no meetups happening and stuff like that. So Python Karachi's core aim has been to set up meetups, and we have a group on Facebook where we have our discussions, we share interesting things, links, tutorials, things like that. So if you are interested in learning more about Python, you can always reach out in the group or to me directly, and I'm happy to guide anyone over here. For those who missed it, end of last year, we also had our first Pycon conference in Karachi, Pycon Pakistan 2019. Um, it went very well. We had over 500 people there. We had some international speakers as well. Not planning to do it this year, just again because of the situation. But we'll see how this wraps up, and then maybe next year we'll definitely try again. So this was it from Python Karachi side. I'm going to hand it over quickly to Junaid to tell us a bit about Elastic Meetup Group as well.
Hello, everyone. Assalamu alaikum. Just a brief introduction about Elastic community, how it evolved. So, I think the first Elastic meetup was held in Lahore in around 2017 time, but in Karachi, it was held in September. And that was the time we thought about having a community in Karachi where we can actually together learn and share whatever cool stuff we have been working with with whatever tools Elastic has to offer. And the first meetup, in-person meetup, was held in September, and then we had a total of two in-person meetups. One was at Semantic, the other one was at Folio 3, and then in this particular, you can say, meetup, it was originally planned to be an in-person back in March, but due to, again, COVID, we have to actually shift it to the the remote ones. So overall, the primary purpose is again learning the newer technologies and sharing it with the different people around. So that again we have some collaborated effort going on that particular front as well. So yep, we are looking forward to have more such events in the future. And after the event, please feel free to join our Facebook pages, both the Python Karachi and Elastic Stack Group Pakistan as well, and do share your valuable feedback on those particular platforms. Also, the recordings of these sessions will be shared, and I think in next couple of days those will be shared on the respective community pages. So, yep, that's it from my side. Back to you, Mashhood.
Awesome. Thanks, Junaid. So we're going to dive right into our talks for today. And we're going to start with a talk on Elasticsearch first. And then we'll have two more talks on Python. So I'd like to welcome Mr. Waseem Asif from Github Technologies to share about using ELK for data processing. Over to you, Waseem.
Thank you, Mashan. Assalamu alaikum, everyone. Hey, guys. Okay, so my name is Waseem. Let me actually share my screen as well. So today we're going to talk about how we can use Elasticsearch for data processing and what features we can use. So because data processing and data science is the area which is growing, and need of processing the raw data into very structured format, then able to search on it, able to represent graphical representation of the visualization of the data is becoming very handy for data science. So Elasticstack is a great tool to actually do all this. Let me start with agenda. Okay, let me start with my introduction as well. I'm, as said, Waseem. My name is Waseem I'm Elasticstack certified engineer. I have about 5+ years I've been working with Elasticstack, which was known to be Elk Stack. I have, before that, I have been working, actually I'm working still with Solar. So 6+ years experience with Solar and 9+ years experience with full text searching, which using Swing Search, Solar, and then Elasticsearch. So in total, I have about 10 years experience dealing with full text searching. So at the moment, I am founder at Github Technologies. At Github Technologies, we focus very specifically on Elasticstack and full text search related and data processing, data visualization kind of projects. And we are located in Karachi. Then before that, I was architect at Folio 3, which is also a renowned software house for Pakistan. Before that, I've been working as product manager at TradeKey, which was a B2B portal. And you can view my LinkedIn profile if anyone is interested. So today, what we're going to see is that why do we need Elasticstack? Then an overview of Elasticsearch, Elasticstack actually. Then a detailed overview of Elasticsearch, Qivana, Logstash. So how we actually use this into data processing, data visualization, searching, structuring, or manipulation, or anything else. So as you guys know that data science have a very specific process. Like first part is to obtain the data, because data can exist in many different formats. It can be a simple file, it can be a API, it can be a web page, it can be HTML, any sort of data which we need to interact with and we need to use. And obviously next logical step of it's to scrape the data and clean the data and structurize the data. That is the area, like these two areas are the basics of Elasticstack. And then there is explore model, where you look into data, you see what kind of data is available, what kind of anomalies we are having, and what kind of issues we are facing with data structure. And in further then we create models based on the data, same data, and structured data. And then we do a lot of machine learning jobs. We can use it in machine learning, or we can use it to generate automatic alerts. We can use it to analyze the situation without human intervention required. And then obviously the driving results from that data interpretation. So all these areas are very much covered by, actually this is Elasticstack is the best tool to cover all these tools in one signified, what we can, is a one-shop solution for all these issues. Okay, so in normal life cycle, we get data something like this, like a lot of logs coming in from somewhere. Like if you are system analyst, or you're system administrator, or you're security administrator of the network, you will see data generated like this on servers. many of you already very familiar with it. And with the, like, we are having a more and more data sources, more and more servers, cloud servers. Not only servers, applications generate a lot of data. So it's only making our life worse, which is to like how many screens we can look at, and you see at this speed you cannot even guess what is going on. So what is my system under attack? What's going on my system? Is somebody requesting a specific page? Or like there's so many use cases where we see a lot of data coming in, and we need to make sense of that data. So in this particular session, I'll be discussing a case where we had very similar situation. Like a lot of data was being generated from system servers, Windows, Linux, everything, firewalls, and hundreds of devices which were very telco specific. So how did we use Elastic Stack to actually make that data very meaningful and extract meaningful information, make it searchable, visualization of the data, and things like that. So in this, you'll see like how from raw text, how we get it to the end result of the data visualization, modeling, etc. I'm a bit far, but if you need any question in between, you need to ask, you can ask. Or if you don't get any point, you can interrupt me and let me know. Okay, so in this scenario, what we had was like there was logs, and logs were having all kind of useful data, like which user logged in from which IP, which user is accessing which server, is that login failing, is that password change or password incorrect, like a lot of things which are very useful for the security aspect and the other information. And the volume was very much a concern, because about daily 40-50 GB of logs were being generated. And this I said the kids. Sorry. So security is a big concern as well, because they wanted the system admins like to know like who is accessing what machine and what resources. And then obviously reporting, visualization, and automatic alerting was required by them. So Elastic Stack has all the tools to achieve all these needs. And see, we can distribute Elastic Stack into different areas. Like Elastic itself offers a packaged solutions as well. For example, logging, metrics, application performance monitoring, uptime, security analytics, application search, sites search, enterprise search, and all these managed, cloud hosted, or you can download as well, and you can try on, you can self-manage those. So these are the package solutions which we can have a major distribution. Then if we go into Elastic Stack, then you'll see that we have beats, a lot of beats. Beats is a tool to collect data. Like for example, we are talking about logs. So it has WinLog beat, which is installed on Windows, and it's processes the Windows logs and send it to Elastic Stack for further processing and visualization. And then there are a lot of beats. So any kind of data you want to see, you want to get, it will help you. So the first part, which is obtain, is fully covered by beats, and some part of is also by Logstash. Logstash is a tool which is used for incoming data processing. For example, we are collecting the data from syslog, from files, etc., and then we want to perform additional operations on that data before we store it into Elasticsearch. So there's a lot of things which can be done. Like for example, if we are getting an IP in our web server logs, we can get the actual location of that IP from Logstash during the enrichment process in the Logstash. So we can produce easily very interactive location-based map of the from where our users are requesting. This is very useful in the web applications mostly, and there are a lot of other implementations as well. And then, so these two parts are like beats and logstash. These are part of ingest, like we are ingesting the data from many different sources. And there are so many sources which you can use with beats and logstash. So doesn't matter if it is Windows or Linux, or is it files, you need to get something from FTP, you need to get something from API or anything. So do explore these two, and you'll see how much life it can make it can make your life very easy. Then Elasticsearch, as you all know, you may know that Elasticsearch is the core of the Elastic Stack. It's called heart of the Elastic Stack. We will go into bit details on Elasticsearch and Qivana later on. So just to give you an overview, like Elasticsearch is kind of storage. You can say database, you can say storage, analysis, and search engine. And then we have Qivana, which is all about visualization, management of the Elastic Stack and everything. So this is your interface for managing visualization and managing the stack itself. And then they're like, you can deploy it on your own, you can deploy it on Elastic Stack, or there are other services available as well. So it's complete solution. It's open source and very useful for the community. So this was the end result. What we you see the screens you saw for the log, we had very much similar, and this is the end result we produced with Elastic Stack. So the visualization, most visualization you're seeing on this screen are generated by Elastic Stack, like Qivana, and I'll go into a bit more details like how we did that. So here, so you can see like any analyst can have a look and see how many requests are coming on, in which ports are being used, which locations are. The chart on the top right is the, you'll see a location chart. So it's showing from where we are getting the traffic, what's the load on the servers. The middle bottom screen is showing the load on the servers, everything. So this is the end result of how Elastic Stack actually got the logs, and then what was the end result which was produced. So give me an like I've covered most of these features, but you see like basic feature is storage, searching, and full text search. Then analytics and visualizations with using Qivana. Machine learning is part of Elastic Stack. It's with required license, but is very useful. And stack management, which I mentioned, like it's from Qivana. Qivana has built-in tools for all the stack management. Like when you have deployed a lot of Elasticsearch machines or Elastic Stack machines, so it's becomes very easy to manage those. Scalability, it's from ground up, it's very scalable. You just keep adding machines and you'll just scale it. Security is like very basic feature and available by default. So it's very secure. Like you can be sure that your data is secured. In role-based access and everything is available. Stack monitoring and alerting is available all the time. And data ingestion is the where I mentioned the beats and logstash. Data ingestion from all of the almost any source. You need to query the database. You need to get from file or anything. You can do it. Reporting, interactive maps I mentioned, and the good thing about Elastic Stack is that their APIs are available in. They use REST API for everything. Like you can manage every aspect of the Elastic Stack from the REST APIs, and like insertion of data, deletion of data, queuing of data, console, like you need to add remove node, or you need to change settings on the index and everything. So you can do it from APIs. You're not depending on any one tool. And it supports a lot of database data sources, a lot of data transformation. The IP example, IP to location example is just one of those. So if you explore, it will give you all tools and kits which you can use for to process any kind of data. Then it has application monitoring for like it can give you code level performance matrices, like what's going on in your code. Then we have uptime monitoring. Then we have security information and event management, SIEM monitoring, infrastructure monitoring. So you just want to see which of your machines are having load, what is the CPU usage, what is the, and then we have Elastic Stack support is also available with the license versions. And so many people ask like what's free with the Elastic Stack and what is not. So I just jotted down a small list. So so free stuff, there is a lot of free stuff with Elastic Stack. Full text searching is by default free. Data ingestion is free. Data sources, any kind of data source is free, like is available in the free license. Data transformation, visualization, application performance monitoring agents, infrastructure agents, uptime, and it's not yet like scalability is like free. You can add as many machines as you want. Clustering and high availability is default feature of Elastic Stack. Automatic data rebalancing, like if you had only one machine and now you have ended up having 1 terabyte data on that machine, and you just add another machine and it will rebalance your data, like it will split data between the two nodes and all available nodes as we add more nodes. So it's all free. Cross cluster search is available in the search. There is also like cross cluster application, like you want to manage multiple cluster in multiple geolocations. So replication is require license, but license is also very cheap as compared to other alternatives. Machine learning, see, basic data visualizer is free, which is itself is very, very good tool. Like if you familiar with data, you know, whenever we get the data, we need to explore like what interesting aspects are available with the data. So data visualizer help you explore your data, like what we have, from where to start with. And then there are some features which require subscription. So that's not part of the discussion today. So we'll just skip through. As I mentioned, like we'll go a bit detail in Elasticsearch itself. So as I mentioned, it's called heart of the Elastic Stack. All the storage is done in Elastic Stack. It's very scalable. It has RESTful APIs for all the aspects, even managing nodes, removing node, adding node, everything. Then it's very fast. You will not find any tool which can handle this much of data at this pace. Like there are so many tools available other than Elasticsearch, but you will find it best of the breed. It provides all the analytic abilities. Like I'll share some screens of Qivana. You'll see the screens which I showed you in previous slides. So you can see that how many, like we are looking at so many different aspects of the data, and we can drill down, we can do full charts, dashboards, and a lot of charts based on Elasticsearch. Then it like log monitoring, it has maps, integration, security analytics, integration, infrastructure monitoring. There's a lot of things which we can do with Elasticsearch itself. And good thing is that all the components, which is Elasticsearch, which is Logstash, Beats, all these can be used independently. Like to use Elasticsearch, you don't need to install Logstash. You don't need to know the Logstash. So you can just start with Elasticsearch and Qivana. So this is one of the screens of our implementation. You will see this is the monitoring screen of Elasticsearch. So you can see, I just wanted to give you overview of like scale it can do, and it can do a lot more than this as well. So for example, in this, we had 8 nodes. 8 nodes mean like we have 8 Elasticsearch machines. And we were, at that time, we were hosting 4.1 billion documents, and which was 3.8 terabyte of data. Like if you have tried any similar tools in the past, you'll see like 3.8 terabyte data is not it's not a small deal. So, and this was screened for very initial. I can tell you like it's more than 12 billion documents at the moment in the same cluster. This was initial initial stages of the project. So it had 4 billion. Otherwise, now it's about 12 billion at least, I can remember. And then there is Qivana, which is your interface with Elasticsearch. Like it's a visual interface. And if you explore Qivana, you will see so many kind of visualizations, which are many which are day-to-day need of any person who is working with data, any person who is working with data sciences or just exploring data sciences. So if you go to and develop these kind of visualization by yourself, by custom implementation, it's gonna take years. But Qivana has made all these visualization very easily available, freely available actually. And you can do a lot of analysis and a lot of charts, custom charts in the Qivana. So, and Qivana is also interface to manage Elasticsearch, etc. So it's very useful to like you just install Elasticsearch and then Qivana, you just log into Qivana and you'll start seeing like what's happening in the Elasticsearch and things like that. So this is your interface. It also hosts the interface for machine learning, graphs, networks, location-based and location-based maps. You can see in the slides as well. So Qivana is like and you can create dashboards, you can download those dashboards, you can share those dashboards, and so many things you can do with Qivana. This is another example of visualization. So you'll see a lot of visualization available by default in Qivana, and you can do a lot by yourself as well. And this also I wanted to demonstrate like Qivana is not just boring charts. So you can do a lot of custom dashboard development. So this is a typical e-commerce company which is selling products in many different categories. So this is very interactive dashboard for the management. Like, okay, we have 11% accessories products, we have 25% clothing. What people are actually buying, how many women are buying, 38% women and are the total customers of the total customer. 62% men are buying our products. What is the revenue? What is the sales, etc. So this is example dashboard for. So this is called Canvas. So you can do a lot of things with Qivana. And this is another example. So you can design on your own. If you don't like Qivana visualization, which is very hard to ignore, so you can do at your own as well. Okay. So remember the first part where is obtain and then the cleansing, scrubbing of data. So Logstash is the right tool to do it. As I mentioned, Beats like it offers you data ingestion from so many sources that I'm insisting on so many sources. Like there's so many, like even I have not explored many of those. For example, S3 file, API, syslog, database, SQS, any queue management services or anything you like. Then you can do transformation of the data, enrichment of the data, which is very critical part of the data sciences and data processing. You can do a lot of regular expressions, date processing, key value processing, HTTP, JSON, comma separated values. There are a lot of enrichment. You can transform the data, then enrich the data into so many things. And then you can ship that data to anywhere. You're not required to ship your data into Elasticsearch anyway. You can put it in some other database. You can send it to email. You can send it to your web service, TCPs. You can send to Solar. You can send to Redis, Redmine, which is ticketing tool. There's so many things where you can do it with Qivana. So it's very scalable. It's very fast. Like I'll show you some screens for Qivana. Like it has been running for many months and We didn't need to interrupt it at all. Like it's so consistent. It has persistent queue, so you don't lose the data which is coming in due to interruptions. And then it has monitoring of its own, so you can know what's going on in Qivana. So this is a brief overview of like how the Elastic Stack looks in the production or looks in the use. So what we do is that we use beats, which are like file beat, metric beat. File beat is to read from file, metric beat is from read from systems. Then packet beat is for network, heartbeat is to monitor the uptime, function beat is for Lambda functions, etc. Audit beat is to scan the systems and look for any changes in the critical file system, etc. So we can use all kind of beats to ship data to Logstash, and then Logstash to Elasticsearch to so many other services. Like you can use it in the Qivana, or you can use it with any application which you like, any programming language which you like. And then we don't need to bind. We are not bound to use beats. So we can connect Logstash directly with our databases, web APIs, sensors, social media APIs, etc. And then we can add obviously buffering in Kafka, Redis, or so many messaging queues, etc. And this is just to show you the scale of the Logstash. So with the Logstash, we were doing about, these are like 4,500 events per second, which is very large as compared to most of the implementations. And this we were doing with only 5 nodes, and using very little memory and very little resources. And this is the stack monitoring of that implementation. So you'll see Logstash uptime. So our Logstash have been uptime for 2 months, and in 2 months it processed about 13.5 billion events which were coming in, and it was passing to Elasticsearch after some processing. And this Elasticsearch, you can see with 7 nodes, actually we have 13 billion documents or records or logs in that cluster. So it's very, very scalable. It's very easy to get started. This is another screen for the same implementation. You can see like events, what is the speed of events coming in. This is for one Logstash node. And how much CPU utilization. You see CPU is very normal range. So we can use a lot of, like, even if it is 3,000, 4,000 per second. So single node is enough to handle a lot of load. This is another screen. I just wanted to give you scale, because data processing scale matters a lot. So many people, like whenever you are selecting a tool, you should be very sure of your scale, how much data it can handle. So this is another example of the same Logstash pipelines. So you'll see like 2,000 events per second, or 2,000, more than 2,000 actually on average. Enrichment, I think we don't need to go into much detail of enrichment. Like if you explore, you'll there are a lot of tutorials available from Elastic, a lot of available, so you can look into more details on this. These are some beats which I mentioned, so you can look into beats to collect data from so many different sources. So you don't need to write your own coding to actually get the data. This is another implementation of Elastic Stack, which is for security and information event management system. And Elastic Stack comes by default, so you can use it. You can secure your infrastructure, monitoring your infrastructure with this system, and with all free. This one I'll skip, and at the end I'll just give you like what Qivana Technologies is at. So at Qivana Technologies, we implement, like, we have been working with Elastic Stack for since very beginning of it, and we are really impressed. So nowadays we do most of the implementation using Elastic Stack. So there are so many cases that other tools can fit in, but Elastic Stack is like give us all the flexibility. So we are doing a lot of Elastic Stack implementation, consultancy for the same, and Elasticsearch, like performance and scalability optimization. There are a lot of users who are using Elasticsearch only for searching. So relevance tuning is something that is very much needed. So we are doing that. We are like based in Karachi, Pakistan, but we have a global customer base from all over the world. And I'm sorry I rushed too fast because I had to run somewhere. That is why I requested to schedule my talk. But I think it would make more sense if I have done it at the end, but I could not. I'm sorry about that. So thank you very much. If you have any questions, please ask. And like all the graphics I use from Elastic Stack. So thank you, Elastic. Thank you. So you can ask me any question. Like.
Awesome. Thank you, Waseem bhai, for the lovely presentation. So we have a question in the comments, and that is, if we don't need any log transformations, can we skip out logstash components as well? Or
Yes, absolutely. You can directly send to Elasticsearch. Even the beats, there's so many beats which support. They can send to Elasticsearch directly. So you don't need to involve the logstash at all. And there are both options. So you can skip it.
awesome. I'm also a little bit curious. So we've talked about that there's a subscription for Elasticsearch. Could you also share usually what is the cost of the subscription for a small medium business if they wanted to get something that was fully functional?
The costing is a bit like, because it depends on industry, depends on region, depends on the company which is looking for that license. But it's very fair. Like if we compare it with other alternates, for example, QRadar or other security products, other logging products, it's very competitive. And we are in like it's worth mentioning that we are reseller partner for Elasticsearch in this region, like Pakistan, India, Asia Pacific and Japan region, and also like we can deal with Middle East, etc. So if you guys, any of you need any further details on costing, or you want to estimate like your implementation, you can feel free to reach me. Like costing is dynamic, it's not very fixed, so I cannot comment on that.
Awesome.
But it's very fair, so it's worth.
All right, perfect. I don't see any other questions, at least in the chat. Does anybody else have any other questions? They can just raise their hands. We can hang them in. Looks like there are no more questions.
Awesome.
That was it. Thank you so much, Waseem bhai.
Thank you very so. I'll be running away, but thank you very much for gathering and arranging. And so it's good to connect with the community.
Awesome.
So thank you very much for the opportunity. Thank you. Bye.
All right. So next up, I think I'm going to go ahead with my talk on Django with GraphQL. Let me just share my screen. All right. Oops. All right. I hope you guys can see my screen. If not, just send a shout out. I'm going to be talking today about, so this is a Python specific talk, and we're going to be talking about two very popular concepts, Django and GraphQL. I'm assuming you already know Django since if you're part of the program, but in case if you're new, worth checking out. So Django is a really awesome batteries included framework in Python, and it's something that we're using a lot. So in this talk, we'll see how we can use GraphQL with Django, how GraphQL works in the Python space in general on a high-level view, and then we'll wrap it up with some issues that I saw with using GraphQL in Python and just my general thoughts overall on that. So my name is Mashhood, and I work as the CTO at a startup called Sustainability.pk. We are working as the e-commerce travel platform for Pakistan. So right now we're doing flights and hotels, but hopefully in the coming months we'll be doing a lot more cool stuff like Umrah, buses, trains, and whatnot. So we are primarily powered by using Python. A lot of our services are in Django as well, and our front end is mostly React. I'm also something called Google Developer Expert for Web and Angular. Google Developer Expert is a program from Google that essentially you get this badge if you're very active in the community and you're sharing a lot of stuff like I do. If you like to know more about the GDE program and more, so I also kind of run this podcast. I started this recently a few weeks ago, and over here you can find out a little bit more about things that interest me, different tech topics, including the GDE program. So getting into the topic at hand today, let's start with a quick introduction of what is GraphQL, and then we'll dive into how do we use it with Django. So GraphQL was something that was released by Facebook, and this happened all the way back in 2015. The basic premise of GraphQL was that Facebook was trying to fetch data, and what they realized was that they were passing back to the client a lot of redundant data over their APIs. So they wanted a flexible way to query data and manage their APIs, and from their perspective, REST just wasn't cutting it. So the whole protocol was essentially designed and implemented by Facebook. It was open sourced and then later transferred over to Linux Foundation, so that Facebook essentially doesn't control it anymore. Now it is an independent platform that is growing on its own. The cool part about GraphQL is that all of your work happens on a single endpoint. So your GraphQL receives all the requests on this one endpoint, unlike what we are normally used to, and it processes all of these requests in a specific manner, and we'll talk about that in a bit. So if you want to get the highest level view, so GraphQL is considered to be a query and manipulation language. So that means that it is not a database, so it does not store data, it only processes the data. And more specifically, it processes the queries. So we define what kind of data we have, and then we're able to query that data in a very flexible manner. And it also has something called mutations that allows us to change that data in a very specific way. And my favorite thing about GraphQL is the built-in type system it has. And type safety is something that we have, I mean, personally, I think have struggled with a lot over the last several years with REST, because on the back end, we're building something, we create models, we create a lot of code, and then on the front end, the developers take some sort of feedback from the backend developers, and they create their own models and everything else. And a lot of the time, there is a mismatch of what the properties hold, what their types are, what their names are, and then when they try integrating, at the end of the day, that's where all the clashes happen. So with the built-in type system, you can ensure that whatever's on the back end is definitely the same on the front end, because the type safety otherwise will not work. So this is something that's very useful. That's part of GraphQL. So we talked about types, and the types of GraphQL are derived from what's called a GraphQL schema. On the right, you can see what a schema looks like. We essentially define what we call types. And over here, I've defined a very simple type called character. This is a movie character. And I have defined two properties on that. One is name, which is of type string, and the other one is appears in, which is an array of episodes. One important thing to add here is the exclamation mark, the bang at the end, which implies that this is a required attribute. So you can obviously have optional attributes, and adding that bang kind of enforces, okay, this needs to be configured when we create this object. So this is part of the validation of the schema. Now, the cool part about the query, which we're going to talk about on the next slide, is that so we don't have to return all the properties here. So and that's where the typing part comes in, right? So once we've defined all the options here, once we start querying it, we can choose which ones we want. So if we just want the name, we can get the name back over here. So if you look at the query, the GraphQL query is, so you have an example on the side, on the right side, and it's it looks very much like JSON, but it's not JSON. So over here, we're querying a hero object with a name and height. So we could have way more properties on this, but we're just fetching these two properties because these are the two ones we need. And this is part of the power that GraphQL has. And right now, we're obviously fetching one model, but we could easily fetch multiple models and even submodels. So if the hero, we wanted the hero's episodes, so we could ask for the episodes, and then inside episodes, we could just ask for the name of the episode or just the ID of the episode or any other information that we wanted, right? So this is essentially what the crust of GraphQL is. It's a very powerful query engine that allows you to query in exact way you want. And it obviously supports all sort of sorting and filtering and get the first one or the last one or whatever in however form you want, right? The final concept is GraphQL mutations. And mutation we use to modify the data in any way, be it creating data, updating data, or deleting it. So mutations here is a very rough example again, where we are trying to create a review for an episode, and we simply call in the create review mutation, and we pass in the episode itself and the review, and on the way back, when it's created, I want specific information from the response. And in this case, I'm asking for the stars and the commentary. So on the example below, the JSON that we're sending the EP, that's the episode, as the Jedi, and the review as the object that's required. And then on the way back, it responds with the create review, that's the mutation name, and then the information that we asked for, that's the stars and commentary, right? And now this create review is actually implemented on the backend side. So while it's called create review, it could be doing anything. It doesn't actually need to create a review. It could be doing 5 other things as well. So that really depends on the implementation on the backend side of things. But from a front-end perspective, this is a descriptive name, so kind of gives you a sense of what it's going to do. One other cool thing is how errors are structured in GraphQL. So if there is any issue in the API, like in this case, in this example, there is an authentication issue, then we have 2 attributes on the top level. One is data, and that returns all the data that we've asked for. And the other one is an errors, and that's an array. And if there are any errors, then we'll essentially get this array filled in. And now, important thing over here is that you will always get a response of status code of 200 from the GraphQL request. So that's no longer something that we check on the GraphQL side of things. And we're always looking at the errors array and trying to figure out what kind of error has happened. so that we can then show the appropriate message to our front end. So now that we have an idea of what GraphQL is, I just want to pitch it against how we build APIs today, and that's REST APIs, and just try to get a sense of what are we doing differently, which should be obvious now, but just as a summary. So in the REST world, when we're creating a CRUD API, we're talking about creating get calls, and then get detail calls, and then delete, update. So for each model, we go ahead and implement all of these APIs. So we have a structure in place that kind of helps a lot, and that kind of helps us get a direction. But at the end of the day, it's still very hard, especially when it comes to creating those very specific functions, very specific operations, which are custom on that model. So then you start going into this this place where you have all of these different URLs and you have no idea what they're called and how to call them. So if you compare that to GraphQL, single endpoint, you can essentially request the schema on that endpoint. And if you're using one of the playgrounds that GraphQL provides, then you'll automatically immediately see all the models that are available on the back end. What are the types? What are the operations? What are the queries they support? What are the mutations they support? What mutations, again, it's a type system. So what is each mutation asking for? So within a few seconds, you have access to all of that data. And this is the main advantage of having a type system. The second advantage, which is also very obvious, is that when we build the REST APIs, we also have to add validation in our serializers, because we have to check if the inputs coming in, do they match the expectations of the model. And very much so in GraphQL, this is kind of built in, because you have to find the types. It will check and validate the types for you. And if it's not the same, it will simply return that as an error and let you know that, hey, you've messed up your type there. I've also mentioned in the previous slide that errors are slightly handled differently. We don't have any HTTP status codes. So that's a different way of doing things. And that kind of gives you a contrast of how are we dealing. So in terms of implementation, you're not just looking to create more APIs. We're just looking at defining the schema. That's the main big difference that is coming in when we're comparing the GraphQL with REST. So if we talk about using GraphQL in Python, this has been around for a little while, and you have several libraries out there. So Graphene is the most popular one. Ariadne, I think that's what it's called, is one of the newer contenders, and it's a lot more up to date, and it's meant to be better, and especially when it comes to things like subscriptions. So you have all of these libraries that are out there, and I've gone ahead and used Graphene because, one, it had the most documentation, and it integrates with Django very well. So and we'll see in a few minutes how seamless it is when it comes to using GraphQL with Django. So the good thing about Graphene is it maintains the same approach of the declarative class-based approach of that is similar to Django. So effectively, whenever I'm trying to create a schema, instead of creating that JSON objects or those JavaScript-like objects for my schema, I will simply declare Python classes. And one of my favorite features in this is that I can actually just give it my model, and it will automatically configure the whole object for me, so type object for me. And additionally, and we'll see that in a minute, is I can also control using a property which properties I want to include or not, right? So there's a lot of flexibility, and at the same time, it's very minimal. So you can just get started super fast and start using it, and then expand it as you get along. So let's see and how the code looks like. So here we're going to start off with a very simple Django model. Everyone's built one of these. So we built a very simple company model with two properties, name and is enabled. And I've defined their types as I do in Python and Django. The next thing is to define the schema. And in the schema, we have all the three things. We have the model types, we have the queries, and we have the mutations. So over here, we define the model type. And Graphene has this special object called Django object type, which essentially takes the model as the class in the meta. And underneath, within the meta, you can also define another property here that will take the attributes that you want to expose to GraphQL. And this is especially useful if you have like a model which has some internal properties that you're storing, maybe some states of different things that you don't want to expose to the front end. Most important thing here to understand is that when you're exposing your schema to the public, then obviously anyone in that public can access all of that data. Obviously, we'll talk about access control as well, but all of those properties will be accessible even though if you're using them or not in your front end. So this is something we have to be a bit careful about. So we definitely need this line drawn between what we have on the back end and what we're sharing on the front end. And we normally do this using serializers, but in this case, we essentially define that within the GraphQL types over here. So once we have our basic model type configured, we will then create the query object. And over here, I've built, again, a very simple query object. And you can see that in this query object, I have subclassed a few objects here. And one of them is the user query and the me query. And this essentially links to the authentication part, the authentication library I'm using. So instead of me creating the user query, I'm just using that from the library. And that's something we'll talk about in a bit as well. But for the query itself, all you have to define is the company's attribute and let it know that you're expecting a list of company type. So that's what's going to be returned. And when you resolve the companies, you simply select all the companies from the company model and return them. And everything else, the GraphQL, the Graphene library will handle for you. So if I request just one of the properties, just the name of the query, then it will know that it just needs to return the name from all the company objects. So, and I'll just add over here, in this particular example, I've added the access control. So I'm looking at the request context, and if the user is authenticated, then I return all the objects, otherwise I don't. And this is normally how you're managing access control within GraphQL. The final part that we need to build in order to have a full CRUD API available for our, well, in this case, it won't be a full CRUD, but in this case, we'll be able to create a company. And that is going to be this mutation. So create company mutation creates a company. That's very obvious. And within this, we first define the inputs. And then in order to validate them, we define the arguments again, so that it knows that, okay, this is what's going to be coming in the request, because we obviously won't be sending the ID in the request itself. And then the mutate function is what we override, where we define all the business logic of how do we go about creating that object. And of course, you can have a ton of logic over here in terms of creating multiple models, editing stuff, updating stuff, deleting stuff, whatever you want. And this is essentially the core of your business implementation. In this case, obviously, we just created a company object, we saved it to the database, and that was it. And then we returned the Graphene mutation again with the information that we've just saved. Finally, at the end, you'll notice that there is a mutation class. So any mutation we create, we have to include it in this class, and then we use the query class, the mutation class, and all of the the type classes we have, we register them into a function, and that effectively generates our schema automatically. And that's one of the strong parts of Graphene, right? So we don't have to go around creating the schema. This will be automatically created for us when we when we run the code, essentially. So looking at the code on the previous screen, there you can immediately see that there are going to be some issues that we're going to run into almost immediately. The first and the biggest one is that there is no straightforward way of managing errors. So if over in the previous slide, I'm obviously raising an exception here if the user is not authenticated, but how is this exception returned to the user? That is not essentially defined very well. So I will get an error in my errors array, but it's not going to be very useful because it's going to be throwing in a lot of garbage in between as well that's related to GraphQL. So this is something that has to be handled manually. So that's something to keep in mind when you're building your own GraphQL implementation. The next thing that I noticed was that there's going to be a lot of boilerplate code if you're having similar mutations, right? Because this mutation over here is just for create company. Now, if I wanted to create a similar one for update company, you can imagine I'll be literally copy pasting this whole thing and then deriving it from there. And then maybe for delete, might have to do it again. So this essentially creates a lot of duplicated code. And again, the good thing about Python is that you can extend the classes. So you can have a base company class, a mutation, and then you can extend that to create the update and delete and create mutations and whatnot. So at the end of the day, it does come into play, but it's not something that comes out of the box. So this is some stuff that you have to do yourself in order to get this nice and clean and tidy at the end of the day. Access control, as you can see, I've added a check over here. This is obviously a very simple example, but if you had slightly more complex access control rules, you can imagine that if you try handling that in the mutate function, that's going to get hairy really fast. So this is, again, something that is not part of Graphene itself, but something you have to figure out outside on your own. So Graphene, again, we've seen how easy it is to get started, and it looks pretty straightforward. It's pretty minimal. You don't have to do too much. Just create the types, the queries, the mutations, and you have your endpoints. You can start updating data. You can start querying data. And behind the scenes, your Django could be linked to anything you want. It could be linked to a SQLite database, a Postgres, Elasticsearch. You don't have to worry about anything because essentially it all comes together. The Graphene library makes sure it just calls the right Django ORM functions, and then that actually fetches the data as needed. That said, it does have quite a few things missing, and this is where things start getting a little bit tricky, especially with things like no built-in file upload. You have to use an external library. And I was watching this video, I'll share that in a minute, and the guy was saying that it's not very well maintained. So when you run into these kind of bottlenecks, that's when it becomes a little bit dangerous. It also doesn't have the latest features of GraphQL, things like the Apollo Federation support that came in over last year. So this is actually available in the newer, the other library that we're talking about. So Graphene, again, has all of these cool, simple, integrated functionality for Django. But at the end of the day, it is missing quite a lot of stuff that you have to go ahead and implement manually. So if you're looking for a project that's a live project, then you'll find that it's not going to be that straightforward. So I was talking about this project, and this is an excellent example to explore. So Sailor is a company. They have this completely open source implementation. based on Django and Graphene, and they have this talk where he talks about all the different challenges that they have had with GraphQL and Graphene, and it's really interesting because if you look at it, all of these issues are a little bit serious at some point, and it's almost like you're trying to hack the GraphQL implementation into Python. So when after reviewing the talk, I was a little bit skeptical of the whole implementation, and that was just because one thing that struck me with me was that Apollo server natively is in JavaScript. It runs in Node.js, so you will always be a little bit behind of what the latest functionality in GraphQL is if you're using anything except for JavaScript. So I feel that because of its native types, the way it's written, the way it's defined, the way the schema is defined, and then your whole front end being in JavaScript, the JavaScript seems to be like the better choice for using GraphQL at this stage. However, in the case of Sailor, and the reason I was exploring this as well, is that when you have a large Django code base, you want to, instead of rewriting everything from scratch, you just want to reuse that on the fly. So, and that's why I started exploring this. And for those kind of apps, I think Graphene does a good enough job that you can just essentially create another layer of classes and mutations and queries on top of the code that you already have. And you can actually end up having a very simple and solid implementation with some work on there. I will add, so one final big thing that I haven't really touched to date was this whole fact that a lot of GraphQL parts, especially when it comes to Django, the subscriptions, and subscriptions in GraphQL, they are pretty cool. You can query a subscription, you can create a subscription, sorry, and then whenever that query updates, it will tell your client that the data is updated, right? So that obviously requires WebSockets and asynchronous behavior. Now, if you talk about using Django with subscriptions, it does technically work, but we all know that Django inherently was built for synchronous workflow. So everything in the pipeline, from starting from Whiskey to your request, to your libraries, to your database handler, they need to be converted to async in order for it to work properly. So, and it's stuff like this that when you start looking at it from a big picture, you start seeing that there are pretty big holes when it comes to implementing Django with GraphQL. That said, I mean, if you are pure Python, then the other library, Arduino, is actually has everything. It has Apollo Federation. It is using Django channels and other async functionality to create subscriptions and stuff. So it looks pretty cool as well. I did not get a chance to explore that, but it's definitely much newer and doesn't have as good an integration with Django as Graphene has. So if you would like to explore this as well, so I over the last few weeks, I've been playing around. I created this GitHub repository where I've created a very basic starter, bringing all of this stuff that I've talked today into this repository. So you can essentially just clone this and see how different things are placed and they're moving, how the different parts are moving. The good part, it still remains. It's very minimal. So in the sense of you don't have to write too much code in order to get things working. So, but it's only when you start scaling upward do you start running into problems of things like the boilerplate that we talked about, or different libraries and functionalities not being available where you have to include other stuff. And that was it from my side. I hope you all found this useful, and if you guys have any questions around this, I'll be happy to answer that.
Yeah, Mashhood. So there are a couple of questions, I think, on the chat. Perhaps, like, if you can take a look at it.
Yeah, I can see the question. All right, so for the first question is GraphQL is a solely JSON-based query? Does it offer complex querying like group by, etc., offered in SQL? So like you just saw, the syntax essentially allows you to define what you want, and then essentially you're calling a function, and you implement the function on the other side. So GraphQL itself does not essentially write any queries for you or do anything that sort. It just helps you define the request. So on the other side, if your database supports group by or whatever, you can write that query and return the data in that format. So GraphQL just comes in between. Another question: the name graph doesn't mean, and this library can only with graph. Yeah, exactly. So this library is not only meant for graph database, and this is just meant to be a middleware between your front end and back end. So effectively, it's a medium of communication, and you can use it with any sort of database, including in-memory databases, right? So we've seen our implementation with Django. Effectively, any database that Django supports, the model will link in and it will start returning that data like it sees fit. Cool. Any other questions or thoughts from anyone? Cool. I think that was it. Thank you guys so much for hearing me out. And I'm now going to hand it over to Junaid Bhai to take up on our final talk for today and share a little bit about open source and Python. Yeah, I think Junaid, you're mute.
Okay. Okay. Hello. Hopefully you guys can hear me.
Yep, we can.
Yeah. Okay. Cool. So I think my talk is generally about learning any kind of technology by interacting with the open source projects and other stuff. So I'll be starting off a bit with my brief introduction. So I think I am a software engineer at Security AI. Other than that, overall, I have around more than 9 years of professional software development experience with more than 4 years of experience with Elasticsearch in particular. And over the time, I have interacted with a number of different open source projects, and also like I've done some occasional contribution to you can tell Elasticsearch curator module and some other stuff as well. I won't say that I am, you can say, an active contributor, but you can call me as an occasional contributor. Other than that, you will find me speaking at different conferences, events as a technology speaker. So that's a bit about myself. So the agenda for today is we'll start with a brief description about what is open source software all about, and what is the difference between an open source software and free software. Are they same thing or they are a completely different thing? Other than that, there are few misconceptions, few myths about OSS software, and particularly people are generally afraid when they are creating an open source project that if they make their source code public, how could they be able to generate revenue? How could they be able to earn money? So we'll try to address those as well, and you'll see few reasons and purposes behind contributing to open source software, why that matters, and what benefits do it provide for the contributor, and how we can contribute to open source softwares, what are the general steps. And then at the end, I'll share brief learning, what I had learned while collaborating and contributing with the Elastic Curator module. So I'll begin with this slide. So there are a lot of different logos over here, including you can say different tools such as Elasticsearch, Qivana, which Waseem Bhai talked in the beginning, and similarly Mongo. It's another database. I think if you have been working with the different container technologies, you would be knowing Kubernetes and Docker, and most of the people have already, I believe, worked over Linux platforms, and similarly SQL, Node.js, Angular. So these are a lot of different tools, and even there are also some programming languages such as Python at the top, and Java and C. They all are actually open source. So they all belong to the open source family. And if you want to take a look at their source code, that is primarily available in some form, either over GitHub or through some other mechanism. But the source code is generally available. And by the way, I would just like to, if you guys can raise your hands, if you have worked over any of the tools mentioned over here. So that would be good. If there's an option of raising hand in Zoom calls, so that would be good. Yeah, I see a number of different people raising their hands. So most of us have already worked in some way on some sort of open source software package. So we'll start then. What defines an open source software package? What are the characteristics of, you can say, an open source software package? So the definitions that I took from the open source software foundations, and it is actually an initiative that was started back in 1998, and primarily you can say Linus Torvald was the man behind uh, who actually laid the foundation of, you can say, the entire open source movement with you can say with the Linux operating system. And then again, we have seen this particular movement gaining, you can say, a lot of momentum in 2000s, and you can say lately we do see that many of the companies have started, you can say, uh, have started formulated their business plans based on based on open source software. So it's primarily a software development methodology through which actually harnesses the power of distributed peer reviews and also provides transparency in software. So the overall outcome of these two things is that the software which results is actually of a better quality. It doesn't have, you can say, dependency, or it doesn't it isn't restricted or influenced by a few set of people. It is available for general community. Whoever wants to work over it, it's particularly available for them. There is higher readability. Again, and anyone who wants to see what a particular application is doing, he can go and actually traverse out the source code, what is available. There is more flexibility. There is less cost involved. And you can say one of the problems that we have seen, that it actually ends a vendor lock-in, which we have seen again happening associated with some particular vendors earlier on. So there are actually few, you can say, few misconceptions as well related to open source definitions, that it doesn't only mean that you can access your code, you can also freely redistribute the source code. And also you can actually extend out that particular any of the open source software. You can extend it out, but again, if you are extending it out, then again you need to fulfill and comply with the license of that particular open source software. Also, if you are contributing to an open source software, it doesn't mean that your rights and and integrity of author will not be protected. It is protected, and uh, and whoever the author is, whoever has contributed that particular source code, so the you can say the the name and you can say integrity is preserved. And one more important characteristics of open source licenses are that they must be technology neutral. They shouldn't be associated and restricted by a particular technology. If we take a look at the open source ecosystem, so the entire open source software, it actually revolves around community. It revolves around the people, a group of people who can contribute and collaborate together in order to generate one of the software packages and library. As well, there are few myths that we consider that, okay, if a software is freely available, if a software is available as an open source package, it would be less secure because there isn't any company, any particular, you can say, company behind it. It is generally thought, but that's not true because we even we consider that open source software is more secure than some of the proprietary software because it has more number of eyeballs going over it, more number of reviews, more number of people are reviewing the code. They are actually collaborating over it, and so stuff like that. The other thing is open source is considered harder to maintain because the responsibility doesn't lie with a few set of people. You can't say that a few people will be responsible for maintaining the entire code, but it's the community which is responsible for maintaining it. The ecosystem has evolved over time, and now we see that again there are many people who are actively contributing it. So the maintenance responsibility is distributed, and we find that with a number of processes defined and with a number of, you can say, mechanisms in place, we find it open source software as more readily maintainable as compared to the proprietary software. The other concern is that there is less support available for open source software. You can say that the support is not less available for open source software, but you don't get it readily available. There isn't any SLA defined in order to get response from the open source community. But we have seen the model have the business models have evolved over time, and we see different companies actually supporting and maintaining different open source packages, and they have their different subscription and licensing options in which they offer you can actually get support by actually paying some amount of money, and then you can get support in a predefined time for that particular software project. Then also it is considered that open source software is not enterprise grade. That's not true as well because there are plethora of open source packages available. Some of them may not be enterprise grade, but again, if you look around, there are plenty of open source packages which are of enterprise grade. Even if we take a look at the logos which we saw earlier on, in fact, all of those softwares are of high quality and are readily available and deployed by many you can say multi-million-dollar companies in production environments. The other misconception is if you are making your software open source, you cannot earn money. The models will change. You will not be earning money by selling software, but there are other methods available through which you can generate revenue for your businesses. Those are primarily based around service-based models. So you can generate a pretty much large amount of money. Even in fact, we are seeing a trend where a lot of companies have actually started moving to the open source platforms, and they have been actually generating. They are quite big names. So this is one of the transition if we see in the software industry. Earlier on, if we take a look at the era from 1980 to 2005, we have seen most of the software that was available through some sort of commercially available off the shelf products. You may have again many of the Windows products available. Then we have many different kinds of softwares like the Office one, Adobe Photoshop, and other stuff. Those are primarily available. You typically buy licenses for that particular software, and then that license would have been associated for a particular system. But over time, we have seen the transition to a SaaS-based model where, again, software services were offered by companies as a service, and again, you can just use those services through those applications were deployed in cloud environments, and then you can use it through some sort of web portals and other stuff. And now we are seeing a transition as well to commercially open source software. And by commercial open source software, we mean those companies that rely on open source software for some sort of their revenue generation and commercial activities. And Elastic is one of the big companies that have been based on that have been operating on this particular model, and they are generally considered in top 50 by OSS Capital. I think based on their latest results, I think the revenues were around somewhere around 400 million for the company. And so moving to some of the core values which open source software ecosystem has. So the core values include collaborations. People must be collaborating together, and there is transparency of code. You can actually track out from where the request was originated, why the request was originated, till the time when it went into, you can say, it went into the release, when the code was actually written, and then when it was merged into the various branches. There is also the principle of generosity and meritocracy, that okay, if you are contributing quality code, whoever is contributing quality code, actually the software gets merged into base branch, irrespective of any kind of discrimination against gender, race, and so on. There is also innovations around. So again, you will see plenty of innovation going in the open source area. You won't find the you can say proprietary software to be innovating at that much higher pace at which an open source software is actually moving on. So we'll see why we need to contribute to open source software. So just want to see. So if we, one of the major reasons behind contributing to open source software is learning how to write high quality software. And by high quality, there are a number of different dimensions of quality. So one particular area is quality in terms of functional correctness and in terms of performance, how well a software is performing when it comes to scale, and how well the software is performing with respect to different cases, and does the software able to address all of the cases. There are other aspects as well, other dimensions, which include software readability. Is my software readable to other as well or not? That's one dimension. Does my software cases automatically tested, or automatic test suites developed for my software or not? And whether I have written a sufficient amount of documentation in order to assist users of my software, that so that there isn't any difficulty they don't face any difficulty behind running that particular software. So those last three dimensions, those are the ones which we tend to ignore when working in proprietary environments. And those are the three areas which you can learn a lot when you are contributing to open source software. There are the other reason is that you also gain to learn about the processes inside behind software development. So each of the organization when we are working with, we tend to have some software development processes defined for our organization, and they are specific to our organizations. And we tend to actually not have any idea about what are the software development processes adopted in other parts of the world and in the other parts of other, you can say, areas of software development industry. So if you want to learn, open source is probably one of the best case through which you can learn around different, you can say, version control systems, how version control system is used in different scenarios, and how we can actually continuously, you can say, write code and get it quickly shipped it into production environment. So in order to do that, there are CI/CD pipelines defined, and if and Jenkins or Travis CI, they are perhaps they are probably used in order to integrate your source code to run quickly the test cases to know what is the state of the quality of your project, and then getting it quickly shipped into release. Also, you get to know about peer review processes, and you get to, when you are interacting with a number of different people, you get to know about what are the different review processes. So how code is generally reviewed uh, by different people. So you get to work with different peers and then understand their mindset, how they are reviewing your code, and then automatic test execution, how it can be done. So those are a few areas, and those aren't only the software development processes that one may have. There can be some other aspects as well. The other aspect is giving back to the community. So that's one of the coolest aspects, that you are developing something for others, which other people are using, and you get to know quick feedback, that who is using, and did they find any bugs, or what is their experience. So again, you can get quick feedbacks through it. And I would just like to share one of the quotes by Adam Grant, is that being a giver may appear to you that it is not good for a 100-yard run, but it's quite valuable in a marathon. So if one develops a trait of being a giver to community in any of the forms, then again, in the longer run, it produces valuable results, both at the individual level and as well as a societal level. The other thing is you get a chance to build an awesome portfolio. You get peer recognition, you get community recognition, and then once you get recognitions, it actually raises your prospects for getting better jobs, and again, working on maybe newer projects, getting involved with other people's, maybe working on a startup or some other stuff. So again, there are better future job prospects for it. The other thing, you meet amazing people, you grow your network, you find mentors as well while you are collaborating. So that's one of the again an awesome benefit of collaborating over open source. Also, you can turn your ideas into reality. So again, we know that a great project typically involves a large number of, you can say, people contributing together. But if you are working in a proprietary environment, you won't be having an access to large amount of funding. So in that particular case, again, if you have a great idea, what you can do, you can follow a 3-step process. You create an open source project for that particular idea, build a network of people around it, and then again, by collaborating with those people, you can turn this idea into life and into reality. So a few things, how we can contribute to open source. So I think this is, I actually was listening to one of the talks, and I think I've mentioned that talk in references section as well. So he gave an idea of, he gave actually, there is a Maslow's hierarchy of need, and he related that particular concept with the programming concept, and particularly contributing in the open source environment. So we find out that if I want to learn to contribute in an open source environment, so there is a hierarchy of need, and typically it comes to our mind that oh, okay, since I want to contribute only as a source, I want to contribute to a particular project, I would only be needing expertise in a particular programming language or a particular, you can say, tool. But that's not the case. When you start collaborating with open source software, you need to know a few different things. And first, the primary thing is knowing about GitHub workflow terminologies. And by the way, if you are restricted to collaborating over GitHub environment, then it would be related to GitHub workflow terminologies. If you are contributing to a project which is hosted over any other, you can say, platform, then you need to know workflow terminologies for that particular platform. But primarily, most of the open source softwares, they have been hosted over GitHub platform. So if you are able to learn about the terminologies on GitHub platform, I think that's a good starting point. And then we have Markdowns. So Markdown are specific tools which we'll be talking about in next few slides. So that comes after getting some insights about GitHub workflow terminologies. And after Markdown, you need to know about some working knowledge, how Git works. And once you know how Git works and how you can actually collaborate on a Git, on a project based on Git, then perhaps comes the coding stage where you can actually code, and then you can contribute it to that particular open source platform. So going ahead with the GitHub terminologies. So there are a few different terminologies when you start working with open source platforms. One terminology is knowing about the repository. What is our repo all about? And once you know about the repositories, then then you can actually again it's simply, you can call it a directory of code. Whatever code is pushed and is available on, and whatever you can see over GitHub platforms, so it is actually a repo. So it's simply, you can call it as a directory of code. Then commit, you can treat it as a point in time of code. What source code is available at a particular time of code, we call it as commit. And then a branch is a particular version of committed code. So you can see that again, if you want to see what if there can be numerous versions of codes at a particular time, because since Git is distributed, so a large number of code, a large number of versions can be worked simultaneously at a particular time. Then we have master, and so we'll see master is the default branch. And then we have pull requests. So when a particular version of code is ready to be merged into base branch, then we generate pull request. And pull request is simply means of generating generating your changes and getting them merged in the base branch. And when you fork a repo, then you are actually creating a copy of repository in your own GitHub accounts. So this is how you actually fork repos, and you get it. You actually create a local copy of, you can say, a repository to your local account, which is available in some kind of open source project. So we talked briefly about Markdowns, and Markdown, you can call it, it is a lightweight markup languages, and primarily this allows you to style your codes and by defining some sort of, you can say, syntaxes and some sort of, you can say, plain text formatting syntaxes through which you can style out your text, which is available through documentations, through README, and other stuff. By default, it is the default language for README documentations for open source software. And these files typically end with .md or .markdown extensions, and you can find out guidelines and details about markdowns on the link which is mentioned over here. Now coming to the intermediate Git. So typically how you work is that you take a clone of a project, and you take a clone of that particular project on your systems, and then you work on those systems, and whatever work that you have been doing it on it, so that particular work is actually available on your local system, and till the time you haven't added it, it is available in your local working directory. But when you add it by a git add operation, then those particular changes gets pushed to some sort of staging area, and that staging area is also maintained on your local system. And when you add those changes on your you can say system, then you can commit it, and then once you have committed those changes, those gets actually uh, those gets added to your local repository. And once that change is added to your local repository, you can push those changes, and then it gets added to the remote repository of your forked branch. And then once you are done with all the changes, then you can perhaps go to your GitHub account, and then from your GitHub account, you can raise a pull request against the remote repository available from the organizations for which you want to contribute. So once you have contributed it, then it's all about coding, and it's all about what you want to code. And then again, so those are few things, you can say, prerequisites that are required before contributing to an open source project. So you can choose a project. Sorry. Sorry.
I think it was just background noise.
Okay. So I think I was just mentioning, then what you can do is that, again, you can choose a project, and the project can be chosen on the basis of your familiarity with the languages and different tools. You can search by a specific language of interest. So if, for example, you are interested in Python, you can go to GitHub, you can search Python, and you will get the different projects which are available on GitHub account for that particular language. You can also look for projects based on the recent trends, which are the projects which are actively being worked on and which are the popular ones. So if you want to learn out some of the technologies which are which is quite popular in the community, and that can perhaps increase your job prospects, you can just visit GitHub and observe the trends. What are the trends? So again, rest everything is all about code. Once you are familiar with it, and then you get familiar with the entire pipeline, you keep on contributing with that particular open source organization. So and it's not only specific to software that you can contribute. There are a number of different other options as well. So for example, if let's say you want a new feature to be added in Elasticsearch, and perhaps there is some use case that you faced recently for which support is not available in Elasticsearch project, then what you can do, you can easily raise an issue. You can raise a feature request from there, or if you find a bug in the software, then perhaps you can just report a bug over there as well. And you can raise any sort of issue, and the community is generally quite respectful. And even if you are a new you are a new person to that particular project, you don't have any idea, you can raise an issue. And it's the best way of knowing about the project. You just research a bit about it. If there are any confusion or you see some behavior which is misleading, you can post out and report problems, and someone from the community will respond to it. And those responses, we see that typically within a day you will get response for that on your query. Even if you find some issues with documentations, I think you can fix gaps in documentations, or if you see there is a need of adding more stuff, or whether you were installing a package and you found that the documentation steps were not clear, so you can perhaps uh, generate steps which are more easier to understand, and you can generate an MD file for that particular documentation, and then those will be eventually reviewed and merged into the source code. And again, contributing any kind of software code you can contribute through as well. So we saw we discussed earlier a bit about markdowns. So typical files which are available. So there is a README file, there is a license file, there is a contributing file. So README file generally carries instructions about how to build the project, how to use it. There is also a license file which deals with what under what license the open source project is released, what are the terms and conditions, if you are adding something to that particular project, uh, and so what are the conditions that apply to you, etc. So before you are using any kind of open source applications in your project, I think you should always refer to the licensing part of it, because down the line, I think if you are not complying with some of the legal parts of it, then perhaps it can actually create problems for you. The other thing is contributing files. Here, all the authors who have contributed are mentioned, and you can find if you have contributed some stuff on a particular project, your name would also be mentioned here, and that's a cool thing to use for you can say uh, maybe getting recognition and other stuff. So I'll just pause over here and see whether we have any questions up till now. I don't see any up till now in the chat. Okay, yeah. So feel free to post any questions you have up till now. I think I'll proceed with my experience with contribution on the with Elastic tools, different tools. And meanwhile, after the call, I'll try to respond to the questions if you have. So this is one of the feature requests. So initially I had a problem. I wanted to have, you can say, a support. There was a use case that I faced that I wanted to fetch uh, all the mapping types that were conflicting for a particular index pattern. So there wasn't any support available for it. So I just asked a questions randomly, and then from there I came to know that there is one more feature available for it. Though my exact question was this was somewhat related to my question, and by use there was another API available that provided something similar to that. So when I used that particular API, it solved my problem. So this is one such use case where you can create out issues where you find any problems with a particular library or anything missing with that particular library. You can raise a feature request for it, and then someone from the community responds back to your question. Also, I found that inside the documentations for Elastic, I found that there is a missing piece. So typically there are a number of queries which include exist term and terms query, and this ignore malformed option was also supported with terms queries as well. But those terms queries was not mentioned as a part of documentation. And when I was just going through the documentations, I found that okay, perhaps that should be added. So I just raised a pull request uh, uh, containing that particular terms query as well. And that was eventually merged in Elasticsearch documentation. So again, anything which is available as open source, the entire community has a responsibility. And if we find anything missing to it, I think we should actively try to contribute to it, be it either on the documentation front or the code front or any functionality that we would like to add. Then I also had some experience collaborating on the Python front on Elastic Curator module. So Elastic Curator is a module that allows you to manage indices in Elasticsearch clusters, and it is written in Python. So before ILM feature was available, by the way, ILM stands for Index Lifecycle Management. Before ILM feature availability, Elastic Curator was quite extensively used. After ILM availability, I think most of the stuff is managed by Elasticsearch itself. If you have ILM features enabled through XPack, you can actually get it done automatically by Elasticsearch clusters itself. But before that, we extensively used Elastic Curator, and we wanted to have some sort of new supports, like for example freezing and unfreezing indices. That's one of the options available in Elasticsearch. So for that I raised a pull request, and if you want to go and see, there's a reference for that particular pull request. I'll briefly go what were my additional learnings from contributing to the source code. Some of the learning was general, which we mentioned earlier. Uh, what could be the purposes and reasons behind contributing to open source platform? But other than that, with respect to Python contributions or the software or contributions with this particular pull request, what I learned was I came to know about Click library, which provides some cool mechanism of you can say passing command line programming options through Python decorators, and you can add simple decorators on uh, uh, classes and functions, and then again the command line processing capabilities are automatically added to it. I also get to know about unit test framework. So Elastic Curator has an integrated Travis CI pipeline, and through which they use to test uh, the curator, the functional working of curator with different Elasticsearch versions as well as different Python versions. So all of them were done in a seamless fashion, and for each commit that was done. And after that, you get to know about whether what was the status, whether some of the test cases were broken down or not. So those are few aspects that I get to know about. The other important aspect is learning asynchronous means of communications and learning to be patient. So again, if you have any query, again, the entire community works on asynchronous means of communications. So you create out issues, you post out comments, and then you wait, and you eventually get a response back from the community. So one of the ways in which open source community works. And the typical proprietary environments, typically they more work on synchronous means where people collaborate together and people schedule calls together. But in the open source worlds, it happens that you actually uh, you actually post your queries and then you wait to get your response back. So that was one other aspect that I learned. By the way, this is just a snapshot of how Travis CI was integrated. And I have just added a snapshot for my particular PR. So you can see that for each run, you can say there was a version selected, and there was a version selected for Elasticsearch, and there was a version selected for Python. And the tests were run for all of these combinations. And once all of the test cases are passing, there is a tick mark added to the pull request, and that tick mark indicates that everything is working with this particular pull request. And if there aren't any other questions by the reviewer, it can be safely merged into the base branch. So yeah, that's it from my side. So do you have any questions? Yeah, feel free to add it on the chat box. And you can also join our Facebook page, which is available. And this is for the Elasticstack Pakistan. We also have a Python Karachi Facebook page as well. So that was pasted on the event link, so you can also join that. So I'll wait here for the questions.
Yeah, I don't think there are any questions at this stage.
Okay. I really like the 0% from that. Yeah, that's true, Zainab. When you are contributing it, you are also helping some other people, as well as you are also learning at the same time. And you are also learning from people from different geographies. And again, you get to know mindset of different people, how they think. And again, it helps you to be detailed oriented and more thorough in your designs. Okay, so I think we are also, the time has also ended. So by the way, these videos will be available, I think, in a couple of days. So that will be available on the Elastic YouTube channel. So you can subscribe to those as well. We'll also paste link on the respective community channels as well.
Awesome. Thank you, Junaid. I think that was a very interesting presentation. Cool. I think, guys, that's about it for today. I hope you enjoyed it and learned something new. And yeah, if you have any questions, feel free to reach out to me over to me or Junaid over our communities or through our social media profiles. And we will try scheduling these meetups more regularly in the coming weeks. And hopefully see you all again over there soon. Thank you all.